In this video, I'll go over how to perform ELISA analysis with MyCurveFit.com. For this ELISA, my kit instructions state to subtract the average blank sample from all other samples on my plate, average the blank corrected values for my standard and unknown samples, perform a best fit curve, and calculate the unknown concentration values using the curve-fit equation. I have my data in an Excel spreadsheet, with the plate layout appearing first, followed by the raw data exported by my plate reader. I've used Excel to calculate the blank corrected values by subtracting the average of wells G1 and G2 from all others on my plate. I've also created two tables, one housing my standard samples and one my unknown samples. The standard samples table has two columns, the concentration or X value of the standard and the average blank corrected value or the Y value. This is the data I'll use to create my standard curve in MyCurveFit.com. The second table houses my unknown average blank corrected data, which will be used to calculate the unknown concentrations from the standard curve. First, I'll navigate to MyCurveFit.com and log into my account. To create the standard curve, I'll select Clear in the Data Settings and copy and paste in my calibrator data from Excel. Note I'm highlighting the column headers as well because MyCurveFit.com will automatically apply these headers as data columns and axes titles. I'll press the shortcut command for copy, in this case Control-C, and in the data section of MyCurveFit.com, I'll press Control-V to paste. Once I've pasted in my data, I'll follow through the steps of the paste wizard to define how my data is arranged. Selecting to use the highlighted data for axis titles, identifying which column contains the x-axis data, the concentration column, and review the settings. I'll press Apply to apply the changes. This data uses a period decimal separator. However, if your data uses a comma decimal separator, you can update that setting by selecting the Advanced option and changing the decimal symbol setting. Now our curve chart has been updated to reflect our entered data, and the column titles and axes titles have been added. The default method is 4PL, which is often a great choice for ELISA assays. Typically, for an ELISA using a 4PL, the axes are set to semi-log, meaning the x-axis is logarithmic and the y-axis is linear. To change the x-axis to logarithmic, I'll select the x and update the axis type to logarithmic. In this data set, it does appear we have an outlier in standard 5. With this curve trend, I would expect the data point blank corrected values to increase as the concentration increases. However, I note that standard 5 is greater than standard 6. If I'd like to remove this point from my curve, I can click on standard 5 and select flag. Next, I'll select to remove flagged points, and you can see that the calibrator point has been removed and my fit looks much better. We can also quickly and easily update the fit method using the fit method drop-down box. For biological assays, the most commonly used fit methods are 4PL, 5PL, and linear regression. I'll select the 5PL fit, and we can see that this fit also appears to be a good match for our data. Let's take a look at the linear regression. So reviewing the updated chart, I feel confident a 4PL or 5PL fit will be the best fit for my dataset, so I'll revert back to one of those choices. You can also update the weight methods by using the weight drop-down box, and easily change between these methods to identify the most appropriate for your dataset. For some datasets, you may find that adding a log transform can greatly improve the fit. To do that, I'll again open the Advanced settings and add the X or Y data transform using these drop-down boxes. For more information on when a data transform might be required, please see the linked video. Now let's calculate the concentration values for our unknown samples. I'll open the Predict drop-down box, and here I'd like to enter my unknown blank corrected values to calculate their corresponding concentration values. I'll go back to Excel and copy and paste in the blank corrected data from my unknown table. I'll select Apply, and now you can see the concentrations associated with each unknown sample have been calculated. And the prediction points have also been added to our chart as blue triangles. With my analysis complete, I can select to share my data through a unique link using the Share option, or export the data to one of these options. I'll select to export to Excel, and once the spreadsheet opens, we can see our curve chart with calibrator and predictions added, the fit results, calibrators data table, predictions from calibrators, which shows how closely the backfit or obtained concentration value is to the specified concentration value, and the predictions data table. With the MyCurveFit Excel add-in installed, you can update the calibrator values directly within Excel, and the curve chart and predictions will automatically be recalculated using the specified fit method, in this case 4PL. I'll update my highest calibrator concentration value to 180, and you can see the automatic updates have been made. MyCurveFit.com is a quick, easy, and convenient way to perform curve fitting for typical ELISAs without needing to install any software. Also, if you prefer to work from directly within Excel so you don't need to copy and paste your data to the web browser, you can use the MyCurveFit Excel add-in to build curve fitting functionality directly within Excel spreadsheets. If this is the case, be sure to check out our other videos linked below. If you have any questions about performing ELISAs in MyCurveFit.com, please contact us at support@myassays.com.